Hello everyone, welcome to the P1 program. This lecture is called P101.2. Okay, this lecture it uses the information of mass, which is a unit that we have described in the last lecture. So I'm going to use this mass and do some basic derivations and do some basic things to make sure that to introduce some concepts to you. Okay, so that's what I'm going to do. So first of all, I want to explain what mass is. Okay, that's a nice way to start, right? So if you have something like a box or something which is solid or liquid or whatever, so there is content inside, right? So there is some physical content inside. This content can be measured, right? The amount of substance inside is called the mass. That's total mass. That's the amount of substance inside a material body. Now, um, that aside, if you consider your body, your own body, you can see that there are particles inside. There is liquid, solid, any form of particle inside. So you can measure the amount of substances inside your body, and you can say that this is the mass I have. So a typical person, sorry about that, typical person will have like 70 kilograms. So 70 kilogram, the mass is measured in terms of mass of the body times the gravitational force, right? Gravitational acceleration. So the force is equal to the weight. So you measure mass in earth, on earth, in terms of weight in earth. So if you have 70 kilogram, that means you have 7 times 10 meter per second square. It's actually 9.8, which you know, uh, but anyway, I'm approximating it to be 10. So your mass here is, this is the weight. Okay, so the mass here will be 7 kilograms, right? So your mass, if you are 70 kilograms, it's 7 kilograms. That's the amount of molecules, the weight of the molecules, the mass of the molecules inside your body. So your body molecules can weigh up to 7 kilogram if you are a 70 kilogram weight person. So that's the introduction of mass. Now I just wanted to do that. Now I'm going to use this mass, and let's consider the case of, I've mentioned SI, right? System International. So in SI system, the mass is represented as in terms of M with a letter, with the notation you have the unit mass. Now you use the kilogram for measuring the mass in SI system. Now at SI in France, they use a solid cylinder. Okay, there is a solid cylinder. There are 6 solid cylinders of equal 1 kilogram mass. Okay, so this solid cylinder has a platinum which is 90 percentage and iridium which is 10 percentage. So it's an alloy. Okay, it's an alloy of platinum and iridium. So this is the standard measure of SI for 1 kilogram. So this is 1 kilogram universally. So if you compare your 1 kilogram with this platinum iridium alloy, you get 1000 grams, right? That's 1 kilogram. Now that's how SI keeps the standard mass. Okay, SI keeps the standard mass using that principle. Now I'm going to ask you something. Okay, what can you do to avoid the corrosion of this cylinder? Okay, they use what something like, the alloy is itself non-corrosive, and also they use a bell jar. Okay, bell jar to protect it from corroding. If there is corrosion on the surface of a cylinder, that means the mass will increase or decrease based upon the chemicals that are forming on the structure. So due to weathering, it can happen, the cylinder can corrode. Okay, so you need to avoid the corrosion. So how can you avoid the corrosion? One thing is to use a protective jar, and the second thing you can use is minimize the area. Okay, be clear about this. If you can minimize the surface area of the cylinder somehow, okay, if you can make sure that the surface area of the cylinder is as small as possible, okay, in that case the corrosion will be small, right? So corrosion will be small if the surface area is small. If area is small, corrosion is small. So how can you reduce the area? That's a very interesting question. I'm using this to explain some basic principles, right? There is no other way I can introduce some concepts without such an application. Okay, so as a cylinder, you can see the area of the cylinder will be like, if you take the surface area of the cylinder, it consists of small rings, right? Small rings makes up to the whole of the cylinder. That means a ring has a surface perimeter which is 2 pi r, right? So 2 pi r, okay, sorry, ring has the perimeter 2 pi r. So 2 pi r times the height of the cylinder, which will give you the area. So that's the area of the whole cylinder because it's made up of smaller rings. Okay, now the whole plus there is this surface, right? This surface and this surface. So these both surfaces are pi r square, right? Pi r square areas. So that's 2 pi r square. So that's how you get the area of uh, the surface area of the ring of the cylinder. And for the volume part, you have the same cylinder. The volume will be the area times height. So each area will be pi r square times the height. So it's pi r square h. So volume is equal to pi r square h, right? So we got the volume, we got the area. Now I'm going to substitute this volume component into the area, right? I'm going to use that. So how can I introduce the equation of area of volume into the equation of area? So you can say it's 2 pi r square plus the 2 pi r h, right? 2 pi r h. You have pi square r h. So you can write 2 v by r, right? 2 v by r. If you write it like that, if you can check it yourself. So v is equal to pi r square h. So it's 2 pi r square h by r. So it's cancels and you get 2 pi r h. So that's the same as the equation here, 2 pi r h, right? So it's the same. So you can write it like this. The area can be written like this in terms of volume. Now why am I going to do that? Because I told you already, I need to minimize the area. So I need to avoid as many variables as possible. So r was a variable and h was a variable. So I avoided h, right? I eliminated h out of this. And the volume is always a constant, right? If you have a given mass, if you have a given mass of material, that means the volume inside will always be the constant. You cannot change that. You only have a certain amount of mass. You can distribute it somehow to make sure that the volume will always remains a constant. The only thing change is the radius, height, and also the area, surface area can change. So I introduced a constant into the term. So that's the volume, right? Now if area is equal to 2 pi r square plus 2v by r, now I am going to do something very new to this topic. So this is called minimization of area, right? So let's assume that we have two variables here, a and r. So let's assume that if a is changing with r, okay, if a is changing with r, a has to change with r, right? In this equation r changes, a changes, okay. So if a is changing with respect to r, that means the value of a will fluctuate, right? Fluctuate like this or something like this. I don't care about anything else. It will fluctuate. That's it. So you can, if you want, you can look at this dependence. It's r square dependent and also 1 by r dependent. So it doesn't matter. We'll discuss those things later. Now the area is going to fluctuate, right? Fluctuate somehow. So how can are we going to use that information, the fluctuation part? Let it be something like a perfect curve, okay, so that it is easy to understand. So if this is the case, okay, this is the case, you can always find the slope at a point, right? A slope at any point. That slope, like this is the slope here, this is the slope there. So you can also always find a tangent line at a point, at any point, right? And that tangent line will give you the slope of the line, slope of the curve. So what does the slope tell you, right? If the slope is like this, that means if you put something over here, it doesn't move in either direction. It doesn't move. If the slope is increasing like this, slope is in this direction, then if you put something here, it will go down. If it is like this, it will go up, right? Sorry, it will go in this direction, right? Sorry about that. So that's how slope works, right? If this is the slope, that means slope is, there is no slope, that means slope is equal to 0, right? If this is the slope, then slope is increasing, so also in the negative direction in here, okay. So you have slope in here. Now how can you find the slope of something? You can find the ratio of y by x for a line. For a line, you can find the ratio of y component to the ratio of x component, and you can find slope. That's an easy way. Now what we are going to do is that we are going to limit the variation to 0, like the variation of the variables y and x, here a and r, to a small quantity. For small r, how much does area change? That's the slope, right? At some point, that's the slope. Now let's find the slope. You can find the slope by taking the derivative. You can take dA by dr. If it is equal to 0 at some point, that means the slope is 0. That means you are at a point where the slope is 0. The only point in this graph where slope is equal to 0 is this point. So you get this point where the slope is equal to 0. That's the straight tangent line. That's the area where we are interested. That's the place, that's the point r where area is minimum, right? Area is minimum at point r0. That would be. So you need to find the point where the area is minimum. Now how can we find that area? So let's write down the equation of area again. It's 2 pi r square uh, plus 2v by r, I guess. Yes, 2v by r. Now let's do the derivation. Oh, sorry, differentiation. So, so, so if you do differentiation with respect to r, and if you can find it is equal to 0, the slope is equal to 0, then that's the point where the area is minimum. So let's do the differentiation, and you get 4 pi r, right? 4 pi r plus minus 2v by r square. So this is equal to 0 is the point, where slope is minimum. So let's solve this equation, and you get 4 pi r is equal to this r, and this r, the r is the same. Sorry about that, I make that mistake all the time. Okay, so it's 2v by r square. These are both the same. Okay, so I'm going to erase that anyway. Okay, and then r. Okay, that's much better. Now if you can rearrange this, you get like r cube is equal to r cube equal to v by 2 pi, right? Yes, v by 2 pi. All right, now that means r equal to v by 2 pi the whole raised to 1 by 3, right? So that's r here. Now we have found out r. Okay, we have found out r. Now let's use this equation and let's reintroduce h, because we have eliminated h from the early part because we don't want that variable. Now we have a point r where area is minimum. Let's reintroduce h and find out what h and r are related to. Okay, if you can find a relation, that means you have found out a straightforward relation between r and h. If we can do that, we can do that. So it's r cube is equal to, so the volume was pi r square h, right? So it's pi r square h by 2 pi, right? So that's equal to r square h by 2. Pi cancels. Now r is equal to, so r square, these are and these are the same. Sorry about that again. That's a mistake I shouldn't make. Okay, so if you found out r square and r cube here, right? So it cancels and you get r is equal to, okay, h by 2. Wow, that's a very good relation. That means a cylinder, any cylinder, right? Any cylinder will always have the relation, right? Any cylinder will always have the relationship between them, so that if the area has to be minimized, if the area is minimum, that means area minimum, that means r must be equal to h by 2. That's very good. That's very promising. So that's a physical law that we can do. Any cylinder, you can take any cylinder, if r is equal to h by 2, then the area is minimum. That's a physical principle that we can derive out of nothing, right? So we have done that. Now i'm going to do um I'm going to do something a bit more intriguing. Let's find out the radius and height of that cylinder at SI. They keep a cylinder, right? Platinum iridium cylinder. I mentioned that. So let's find out the area. Sorry, the you can find the area as well. Let's find out the radius and height of that cylinder out of nothing. We don't go there, we don't measure it, but we are going to find out the radius and height, what the relation is. Okay, let's do that. Okay, this is a long video. I hope it is entertaining enough. Now how can we do that? How can we find the area and the height and radius? So we take the volume which is equal to 1 kilogram cylinder, 1 kilogram, right? So that means it is equal to, so we have an yesterday last class we have mentioned about the density is equal to mass by volume. So volume must be equal to mass by density, right? Also you can say that density times, okay, so the density of that cylinder will be density of platinum times zero point 0.9, because it's 90%, right? Plus density of iridium times 10%, that's 0.1. Okay, 0.1. So you can find the density. I have here the densities and I have made that calculation earlier. So the density will be, you can calculate the density of platinum is 21.45. So 21.45 times 0.9 plus density of iridium is 22.55 times 0.1. 0.1. Okay, 0.1. So that means if you can calculate it yourself, it's all right, it's good stuff. So you get 9 by centimeter cube. So 21.56 gram per centimeter cube is the density of that cylinder. Okay, cylinder. So we got the density, right? Now we can find out the volume, right? We know the mass, right? We know the mass. Let's find out the volume of that cylinder. So we know the mass, which is equal to 1000 gram. So it's mass by volume. Mass by density is volume. Okay, so it's 21.56, and you get 46. Oh my, 46.38 centimeter cube. In centimeter cube you get. Okay, so that's the volume of that cylinder. Okay, you got it, right? Now you got the volume part. Now let's find out if you've got the volume. Now let's find out the radius. So you know that radius r cube is equal to volume by 2 pi. So it's 46.38 by 2 pi, right? So you get raised 1 by 3. There is a one. Raised 1 by 3 is equal to radius. So you get that radius is equal to 1 point, you can do the calculation yourself, 1.95 centimeters. So that's the radius of that cylinder. It's very easy, right? We found it straightforward. We didn't go there, we didn't measure it. We know it's 1 kilogram. That's all we know. We know 1 kilogram. Now we found out the radius. If the radius is 1.95, then radius and h has a relationship like h by 2. So radius is equal to h by 2. So h will be 2r. So it's 2r. So that's equal to like 3.9, right? 3.9 something, 9 centimeter. So we have found out the radius and the height of the cylinder, 1 kilogram cylinder at SI they use for measuring, comparing the standard mass. Okay, so we have did that out of nothing. So I hope you enjoyed this lecture. This is an easy representation of what basics that you need to know, and let's see you next time. Okay, thank you.